We are approaching the end of our unit on statistics and probability. Tree diagrams are the last thing that we're going to cover. They're not complicated, but they are time-consuming. So bear with me while we try to draw some tree diagrams. All right, let's say that, and I don't know if I will have enough room to keep all this up here. Let's say that we were planning to buy some jewelry. So the first thing, we have some choices. We can buy a necklace, a ring, or a bracelet. We can buy white gold or we can buy yellow gold. We can get diamonds. We can have just plain gold, or we can get gemstones, maybe a ruby or an emerald or topaz or something like that. So these are the choices that we have. So we want to know how many different choices we have out of all of these selections. So we don't want to keep guessing and say, okay, I could get a necklace, gold, diamonds. I could get a bracelet, white, gemstone. So we're going to just try to look at an organized way to jot all this down. And I'm going to have to cover this up to start with. Okay, so to start with, I'm going to put an N and an R and a B. And that just means, let me see if I can shrink it. That's going to be too big. You won't never see what all I write. So let's try that again. We got a necklace, we got a ring, and we got a bracelet. Okay, so that's our first choices. Now our second choices, if we get a necklace, we can get, I'm going to put a W for white gold, and I'm going to put a Y for yellow gold. Now, same thing, if we buy a ring, we can get white gold or we can get yellow gold. Same thing for a bracelet. We can get white gold or we can get yellow gold. Okay? So now that's my first choice, my second choice, and now I can get diamonds. I could get a necklace. I could get white gold. Now I could get diamonds. I could get plain, and I could get gemstones. Now if I got a necklace and I got yellow gold, I could still select from diamonds, plain, and gemstones. Same thing for ring. Ring, white gold, I got diamonds, I got plain, and I got gemstone. Same thing here, diamonds, plain, gemstone, diamonds, plain, gemstone. And then we're about out of room. We got diamonds, plain, gemstones. So that lists all of our different options. Now, if I ask like how many options we have or how many outcomes, if you come and you count this last line, which ours, it should be a straight line, but mine's not because I didn't have enough room. So if I count everything, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 outcomes. Okay, so 18 different things. Or 18 different choices. Okay. Now we are going to ask questions about this later. I'm not going to, not on this one, but in the next couple. I'm going to show you a shortcut. If it just asks outcomes, here's 3 choices, here's 2 choices, and here's 3 choices. So if I wanted to know the outcomes, I could say 3 times 2 is 6, and then 6 times 3 is 18. So here we wrote them down, but that's the quick way to write just 18 outcomes. Now if I go into more detailed questions, then I am going to need the actual tree diagram. But I'm not going to ask you questions until we get to the last one. Okay, so this time we get to flip a coin. So when we flip a coin, we can have heads or we can have tails. So I'm going to jot down heads or tails. Okay, if we roll a dice or a die, we get 1, 2, 3, 4, 5, 6 because there's 6 sides. So I could get heads and I could roll a 1, a 2, a 3, a 4, a 5, or a 6. Same thing for tails. When I roll that die, I could get 1, 2, 3, 4, 5, 6, and my tree diagram's getting ugly, but that's okay. Now to get my outcomes, I would count this last line. So that's going to be 12 outcomes if I count all of those straight down. So I could get heads in 1, heads in 2, heads in 3, heads in 4, heads in 5, heads in 6, or tails in 1, tails 2, tails 3, tails 4, tails 5, tails 6. That's all of my different options. So now the shortcut way is heads or tails. There's 2. And if we count all the sides of that die, that's going to be 6. So 2 times 6 gives us 12. So that's 2 different ways to think about it. Now this one, after we draw the tree diagram, I'm going to start asking you some probability type questions, okay? So let's say that we were going to, first of all, decide we were going to the beach. It's almost summer. And we're going to decide which beach. So I've got Topsail, I've got Carolina Beach, I've got Atlantic Beach, and I've got Wrightsville Beach. Okay, now the first activity, we can either get snow cones, I'm going to put snow cones, or we can go to Wings. And when I say Wings, I'm talking about like those little shopping store. Okay, same thing, if we go to Carolina Beach, the first thing we can do is get snow cones, or we can go shopping at Wings. Even if we go to Atlantic Beach, we can get snow cones, or we can go shopping at Wings. Same thing for Wrightsville Beach, snow cones and shopping at Wings. All right, now I'm going to run out of room. I hate that. Wish I could shrink. I was hoping maybe I had it blowed up, but I don't. Okay, so our second activity, we can either jump waves first when we get to the beach to go in the ocean, or we can build a sand castle. So we got waves or sand. So each one of these, if I go to Topsail and I go to Wings, I still got a choice of jumping waves or getting in the sand. So on every end piece, I'm going to put waves and sand. And I'm going to just put WS to save time. Oh, see. I hate that. I don't have enough room. So our outcomes. Let me see. I'm going to try to tear this. I don't have any scissors, but let's see if I can tear it right quick instead of taking time to get scissors. All right, my last row. If I counted up my last rows, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, now let's see if that works for us. We got 4 times 2 times 2. So 4 times 2 is 8, and then times 2 is going to give us our 16. So that's how we can see our outcomes. So, and I'm sorry I had to tear this in half. Maybe I could have written it a different way, but anyway. So our outcomes we said was 12. So now if we start doing this like probability questions, the first question says, well, I got 12 outcomes. I'm going to hide that because I've already told you that. Well, I can't really hide it. I did not think this out very well, did I? 12 outcomes. So maybe if I fold it. If we have 12 outcomes, when we're doing probability, that means 12 is going to go on the bottom of all of these questions. So we have 12 outcomes. This says, what's the probability of going to Wings? So I have to find whatever has wings in it and count. So that would be Atlantic, Wings, and then waves and sand. So that would be 1, 2, 3, 4. Go to all of them that say Wings, 5, 6, and then there's Wings again, 7, 8. So there's 8 choices that include going to Wings. So that would be 8 out of 12, or I could do 8 divided by 12. And that would round to 67%. Okay, now it says the probability of jumping waves. What would that be? So we know 12 goes on the bottom because there's 12 outcomes. So we have to find every time it says waves. So there's 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 8 out of 12 again, which we just said was 67%. Remember, we divide and move the decimal 2 times. All right, the next question says, what is the probability of going to Atlantic and Wings? Well, let's do this one first because this one's easier. This says Wrightsville or Snowcone. So Wrightsville Beach is going to be all of these. So if we got our 12 on the bottom, there's 1, 2, 3, 4. So we got all 4 of those. And then snow cones. So we got to find everywhere there's snow cones and add those up also. So we got 4. Here's snow cones. 5, 6, 7, 8, 9, 10. So that's 10 out of 12. So let's do 10 divided by 12, which that's going to be 83% of our choices will include Wrightsville Beach or snow cones. Now the next one, it says the word and remember when it says the word and, both things have to happen at the same time. So I have to be at Atlantic, so that means that Wrightsville, Topsail, and Carolina Beach are not going to be in the mix this time. So I'm at Atlantic and Wings. So Atlantic and Wings, and then waves and sand. So that would only be 2 options out of all of those. So that would only be 2 out of 12, which 2 divided by 12 equals 17%. So real quick, tree diagrams. You have to draw them and then answer the probability questions. If you have any more questions, just email me.